channel. This is the Carbon Math. In today's video, I will be showing us how to determine the exactness of an homogeneous equation. And the equation that I'm talking about here is of this form. We have m dx plus n dy equals to 0, where m and n are function of x and y. We can also write m and n this way. We can write it as m x comma y and n x comma y. We still have it this way. It's telling us that m is a function of x and y, and also n is a function of x and y, right? So if I write just m and I write just n, it still means the same thing as this. Alright. So let's move on. Let's take a look at this example. We have x squared y dx plus x minus y dy equals to 0. Now in this example that is being given, let's write out our m and our n, right? Our m equals to x squared y, while our n is equals to x minus y. So you don't have to get confused, right? How do you know your m and how do you know your n? Your m is always the one having dx right in front of it, and your n is the one always having dy in front of it, right? Okay, now, how do you actually find out if a given equation is exact or not? Now, this is the condition for exactness. That means the partial derivative of m with respect to y equals to the partial derivative of n with respect to x. Don't worry, if this is not making sense now, we have a problem here which we use to explain what we are trying to say here. So let's take a look at this problem. We have to verify whether x squared dx plus 2xy dy equals to 0 is exact or not. So the first thing we are going to do is to follow this, right? Now let's write out our m and n. Now given this, obviously our m is x squared, right? Our m is x squared, while our n is 2xy. That's equal to 2xy. Alright, now I'm going to find the partial derivative of m with respect to y. That means we are going to find the partial derivative of m with respect to y, which equals to the partial derivative of x squared with respect to y. Now, we are dealing with partial derivative here, not just the normal derivative that we are used to. Now, this implies that when we are finding the partial derivative with respect to this y, it means that x will be taken as a constant, right? Now, for example, we know that we want to differentiate 2x with respect to x. You can also write it as what? 2, then we differentiate x with respect to x, right? Because now 2 is a constant, so we can bring it out, right? So the same thing will happen here. Since x squared is a constant now, because we are differentiating with respect to y, x squared is a constant. So I can write like this: x squared, then I write, now we have just 1 here, right? With respect to y. Now it is very easy for us to see that the derivative of this will be 0, because this is 1, a constant, right? Equals to 0. So that means since x squared is taken as a constant, it will be 0. So it's very easy for us to see it the way I've done it here. When we factorize that x squared, which is the constant, so that we already know that differentiation, we can now see that 1 is a constant, right? It's very easy for us to see that. So when we differentiate this with respect to y, it becomes 0. Are you getting it now? So that means the partial derivative of m with respect to 1 is equals to 0, right? Now let us take the partial derivative of n with respect to x. So we have the partial derivative of n with respect to x is written as the partial derivative of 2xy with respect to x. Now we are doing partial differentiation here, right? Now that means with respect to x, then y will be taken as constant. That means in this case, 2 and y are our constants. So let us bring them out. Remember the rule, let me bring back let me bring back the good thing. You know that for the normal differentiation, right? If you have 2x with respect to x, we can bring down the constant and say that we have just x here over 3x. So the same thing will happen here. So we are going to bring down our constant 2 and y. We have identified 2 and y as our constant. So we bring 2 and y out. Then we take the final derivative of just x, right? With respect to x. So there's no confusion now. We have reduced everything that will give us confusion. We have taken them away, right? So it's very clear that we are just differentiating x, right? So, and when we differentiate x, what do we get? We get 1. So 2y times 1 is 2y. That means the partial derivative of m with respect to y is 0, while the partial derivative of m with respect to x is 2y. Are they equal? Since we know that 0 is not equal to 2y, then therefore the equation is not exact. So that will be our conclusion. Since we have this case, then the equation is not exact. Now we have come to the end of this video. If you know you like what you have just watched, please subscribe to my channel and also like, comment and share this video. So see you guys next time. Goodbye.